Now that we have a solid understanding of what scripts are and how they work within Unity, let's look at how we can use them to do something actually useful as opposed to just writing to the log. Here we have just a general scene in the Zombie Toys project, and we have a cube that's sort of off to the right that has sort of an odd position with a non-standard rotation, specifically 45 degrees about each angle. We're going to use a script to bring this cube to a certain position and a certain angle, and then we're going to use the same script to apply some movement and some rotation to it. I'm going to create a new script, again just by right-clicking in the project view and selecting Create C# Script. I'm going to name this script Translate and Rotate. With my Translate and Rotate script open, we can go ahead and start adding the code that's important to us. You might notice that the format looks a little bit different than the default script. I've gone ahead and removed the comments and set the structure of this to be similar to the rest of our scripts. We have a specific standard that we use in our project, and we just want our scripts here to look like that. If at any time you notice that the way the script in this chapter looks is different from the one you might have on your computer, just understand that we may have tweaked the formatting behind the scenes. So the first thing we want to do in the start method is we want to move whatever object this script is attached to around the origin. We're going to place it near the origin, slightly above it so it's not in the ground. We're going to do that by modifying the position value, which is part of the transform component. Now, unlike methods, which generally require us to use parentheses to set values, the position of the transform component requires a value. Therefore, instead of parentheses, we're going to assign to it using the equal sign. Now, the position value requires a variable type called a vector3. I know we haven't talked about variables too much yet, but a vector3 is basically a complex variable type that stores inside of it an x, y, and z value. It's very useful for storing things like scale and position. To create one of these variables, we're simply going to type new vector3. And we're going to pass into these parentheses the values we want this vector3 to have. Since we know we want to move the object basically to the origin, just slightly above it, we're going to give it a value of 0f, 2f, 0f. This will place it at 0, 2, 0 about the x, y, and z axis respectively. You might be wondering about the f. We haven't talked too much about floats yet, but just know that when we're using a floating point value, which vector3 requires, we have to place those f's so that we don't get any compilation errors. Inside our start method, we also want to set the rotation of this object. We're going to do so by setting the rotation value of the transform. Again, this is not a method, so we're going to use the equal sign. Now, unlike position and scale, rotation is not stored as a vector3, which you might assume. Instead, rotation within Unity is stored in something called a quaternion. Quaternions can be fairly complex to understand, so thankfully Unity provides several methods that we can use to create our quaternions without necessarily needing to know how they work. Instead, we can just work with the Euler angles which we're familiar with and have Unity turn those into quaternions. Now if you're thinking, I have no idea what an Euler angle is, you probably already do. If you're familiar with the concept of 360 degrees of rotation about an axis, then you already kind of know what an Euler angle is. You just may not have known they were called Euler angles. In fact, if we go back to Unity and we look at our cube, we can see that the cube currently has a rotation of 45 degrees about the x, y, and z axis. That is actually in Euler angles as it's being represented to us. Within Unity, anytime we see a rotation inside the inspector, we're really seeing Euler angles, though it's important to understand that behind the scenes, they're stored as quaternions. The reason for this, of course, is that quaternions don't suffer from a mathematical error, which is called gimbal lock. All of that is kind of beyond the scope of this section, though, so just understand that we work with Euler angles, though behind the scenes they're stored as quaternions. To create a quaternion, we're simply going to use the quaternion class name. You'll notice that we don't need the new keyword like we did with a vector3. We're using the quaternion class to create one for us. And we're going to tell it that we want to pass in Euler angles. Euler can look like it should be pronounced Euler, but it is in fact Euler. Now let's go ahead and give this object a rotation of 0 about the x-axis, 90 degrees about the y-axis, and 0 about the z-axis. Now we can save our script and go back to Unity and see how it works. Currently, this cube does not have the script applied. We can apply the script simply by clicking on it in the project window and dragging it over to the cube in the inspector and letting go. We saw this in a previous section. Another way we can add this script as a component is we can go to Add Component, and then Scripts, and then choose our script from a list of scripts. Now before I click this, understand that this scene is currently in the same project that we're using to build the Zombie Toys game. Therefore, there are already quite a few scripts in here. So you're going to see a lot of scripts, and that's fine. We know the name of this script is Translate and Rotate. So I'm going to click on Scripts, and I'm going to choose it from the list. Now when I hit play, I will see that the cube has moved to the origin, it is slightly above the origin, and has a 90-degree rotation about the y-axis. You can see this in the transform component of the inspector. Now let's continue with this example by allowing our cube to continue to move and rotate while the game is running. Now inside our script, if we want something to happen over and over again over a period of time, we're obviously going to use the update method. In the update method, we're not going to use the position value of the transform because that would cause our cube to sort of teleport around the scene. Instead, we're going to use the translate method that is part of the transform, and that's going to allow us to move over time. Inside the translate method, we need to specify how much we want to translate by. In this case, let's say we're going to translate by 2 units along the x-axis and 0 along the y or z-axis. Now let's go back to Unity and see how that works. You'll notice the cube just went flying directly off the screen. As a matter of fact, if we look in the inspector, it keeps going and it's a very, very, very small value as it rockets away. The reason it moved so fast is because we specifically told it to move 2 units. Now that 2 units is being moved every single update frame, which happens many, many, many times a second. If we wanted it to actually be 2 units per second, then we need to write it a slightly different way. To reduce a value by a certain amount to make it that value per second is very simple. All we really need to do is multiply it by time.delta time. Time.delta time stores the amount of time in seconds since the last time this update frame was called. This has several different uses. First and foremost, it slows our value down, so instead of moving 2 units every single frame, we're now moving 2 units per second. The second hidden benefit is that if I were to not have this time.delta time and I were to run this script on different computers, this cube would move at different rates because different computers run at different speeds. So everyone would have a very different gameplay experience. By multiplying this 2f by time.delta time, I am saying 2 units per second regardless of the computer you're on. And now everyone will experience the exact same gameplay. So I'm going to go ahead and save my script and go back to Unity. We'll hit play, and we'll see now that the cube is moving at a much more steady pace. The last thing we want to do is we want to apply a rotation over time. Again, we're going to come back to the update method, and we're going to use the rotate method that is part of the transform component. Now this method will take from us Euler angles and do all the quaternion math behind the scenes. So we just need to focus on how many degrees of rotation we want around which axis. In this example, let's go ahead and rotate approximately 25 degrees per second about the y-axis. Now we'll go back to Unity and we'll see what it does. Now we see it moving very, very quickly. Again, when we said that we wanted 25 degrees per second, but then did not type time.delta time, we in fact did not actually get what we wanted. We'll notice in the rotate method of the transform component that we are simply saying every single update frame rotate 25 degrees. That's causing our cube to spin uncontrollably fast. Instead, what we mean to say is 25f times time.delta time. Or 25f times the amount of time it's taken from the last frame to get to this frame, thus slowing our value down substantially. Now when we run it, we'll see it's a much metered turn and we get a nice curve.